The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are 2 different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. Okay, we're going to start with several questions. And the first one, I'm going to put it up here on the screen. They have to do with inequalities and graphing compound or double inequalities. So I'm looking at 22, part A, and it says x plus 2 less than or equal to 10, or x minus 4 greater than or equal to 3. So let's go back and look at those. So solving the inequality on the left, x plus 2 less than or equal to 10, we'll subtract 2 from both sides and we get x less than or equal to 8. Solving the inequality on the right side, we'll add 4 to both sides and we get x greater than or equal to 7. And I'm going to bring down that or. So this is what we're going to determine the solution from. Let's take a look at the graph of x less than or equal to 8. Okay. We got 0, and let's see here, we'll put a 7 there and an 8 there. X is less than or equal to 8. We'd have a bracket at 8 with an arrow going to the left. Okay, so everything less than or equal to 8. Then graphing x greater than or equal to 7. Let's see here. Greater than or equal to 7 will have a bracket at 7 and an arrow going to the right. It's important to notice that this is OR, which means what? Union. If we take all of this along with all of that, we get all real numbers. So the graph would be a solid, well, a line over the entire thing. Now, the interval notation would be negative infinity to positive infinity, like that. All right. Now, the instructions, let's go back and take a look again at what the instructions say. It says, solve the inequality in part A, then use your work from part A to determine the solution set for the compound inequality in part B. No new work is necessary. Okay, part A, we already did that. It was a union. So it's all real numbers, a solid graph, and here from negative infinity to positive infinity. Part B, it has the same inequalities, but now it's an and. Okay, so it's an intersection. If we go back here and take a look, where do these two intersect? Between 7 and 8. So the graph would look like this. Bracket at 7, bracket at 8, and interval notation would look like that. Okay, so brackets because it includes 7 on up to it includes 8. Any questions about that problem before we go on? Okay, let's see here, make sure I've got the screen up. We're going to take a look at some more here now. Okay, let's see. 47, 75. And 8.4. Number 12. Okay. I'm looking at this because the student has it correct, but maybe they figured out. Anyway, we'll take a look at it. It says, solve the compound inequality, write the solution set if one exists, and interval notation, and then graph it. And this is a multiple choice. So let's see, we've got -4, parentheses, x plus 7, close parentheses, greater than or equal to 4, or 2x plus 5 less than 11. All right. Solving the inequality on the left, I'm going to distribute the -4. So -4x minus 28 greater than or equal to 4. I will add 28 to both sides. -4x greater than or equal to 32. Divide both sides by a -4. Since you're dividing by a negative, you're going to change the direction of the inequality symbol. And then 32 divided by -4 is -8. So we get x less than or equal to -8. Solving the second inequality, we'll subtract 5 from both sides. 2x less than 6, divide by 2, x less than 3. So this is what we're going to consider for our solution. Okay. X less than or equal to -8. Let's see here, we'll put 0 and 3 and -8. That would look like that. So it'd be everything less than -8. X less than 3. That would look like that. So the top one includes -8, but everything to the left. The bottom one doesn't include 3, but everything to the left. It's or, so it's a union. Well, if we put these together, this bottom one includes everything that's in the top one. So the solution would be the bottom one. You'd have the graph and then interval notation, -infinity up to 3, which is why if we look at the solution in WebAssign, we see that this one right here, the interval notation -infinity to 3, and the graph parentheses at 3 with a solid or an arrow going to the left. Okay, we've got one more to look at here. And let's go back here. Okay. Sorry, I'm going into student view here, and this is going to take a minute to get there. Let's see. Number 21. Okay. So this student's question has to do with how do you graph fractions when, notice on the number line, there's only whole numbers, actually integers, but multiples of 2. Well, hopefully, obviously, if this is 0 and this is 2, this is 1, 2, 3, 4, etc. But what about in between? Okay, now, first of all, let's solve this inequality. -4 less than equal to 1 minus 3x over 5 less than or equal to 4. I want to point out something. I already know what the answer is. Given these options, it has to be the top one. Why is that? Because see how it's got a less than or equal to, less than or equal to? So that means that it's going to be in the middle. It's going to have, well, it's going to have some endpoints. This is the only one that has definite endpoints. We'll go ahead and solve it, but just looking at all these options, it's got to be the top one based on that. But that isn't always going to be the, you won't always have that advantage. Okay. So I'm going to multiply all 3 parts by 5. So I get -20 less than or equal to 1 minus 3x less than or equal to 20. I'll get rid of the 5 in the denominator there. I'm going to subtract 1 from all things. So I'm going to get what? Negative 21 less than or equal to negative 3x less than or equal to 19. Then I'm going to divide everything by a negative 3. So that's going to give me what? A 7 greater than or equal to x greater than or equal to negative 19/3. Okay, but I want to write this from smallest to largest, so I'm going to rewrite it negative 19/3 less than or equal to x less than or equal to 7. So that's what my solution looks like before I put it in interval notation or graph it. Okay, any questions so far? So in interval notation, it would look like this. Okay, so we'll go back here, and as I mentioned, so that's going to be that choice right there. Okay, now the question is, how do you graph that in WebAssign? Okay, so first of all, let's take a look just on my whiteboard. Let's see. So 7 bracket at 7, negative 19/3 bracket. Okay, so it's solid between negative 19/3 and 7. But graphing that in WebAssign, let's see, negative 19/3, if we change that into a mixed number, it would be negative 6 1/3. Is everybody okay how I got from there to there? Okay, so what I've got to do, going back here to WebAssign, first of all, let's see, let's do the right end. That's the easy part. That's going to be at 7, so right there. Okay, now negative 6 1/3, there's my left bracket. If this is negative 6 and this is negative 7, I need to go approximately 1/3 of the way between negative 6 and negative 7, which is right about there. Okay, and then I need to fill in a solid line in between that. So I'm going to draw. Okay, now I want to show that that answer is correct. So I'm going to go submit answer. So I started playing with this yesterday to answer this student's question, because, you know, it doesn't, there's no way of us looking at that to know it's exactly at negative 6 1/3. So then I started moving things around. I said, okay, well, what if we go like over here and then try that? Okay, that's wrong. What if we go over there? How about that one? So what I discovered is that it's not an exact science in terms of graphing these inequalities in WebAssign. It's like if you're really close, it counts it as being correct. So basically, you've got to estimate, you know, where is 1/3? Well, if I go all the way over there, obviously that's more than 1/3 of the distance between negative 6 and negative 7. But, you know, it'd be nice if like some numbers showed up as you moved it as to where they were, but it apparently doesn't work that way unless I've missed something. If I have, please let me know. But that, so we've just kind of got to estimate it and then put it approximately where we think it would be. Okay. All right. Anyway, I believe that takes care of the questions that students had. Do you have any questions before we continue on? Anybody? All right, then I'm going to close that up and we'll go back to our screen. Okay, so now we're going to look at section 8.5, which is solving absolute value equations. I want to do a little bit of a review of how absolute value works. Absolute value, the absolute value of a number, excuse me, is the distance from that number to 0 on a number line. So let's say I've got this number line, and here's 0, and here's 3, and here's -3, okay? The distance from 3 to 0 on the number line is 3 units. So the absolute value of 3 is 3. The vertical bars mean we're taking the absolute value of the number. The distance from -3 to 0 on the number line is also 3 units. So the absolute value of -3 is 3, okay? Distance isn't measured with a negative value. It's either positive or it could be 0, as in the absolute value of 0 is 0. But the absolute value of a number is either going to be positive or, in this case, 0. How about 0? All right. Now, let's take this situation. Okay. So what is the absolute value of -8? Well, it's 8. What's the absolute value of 8? It's also 8. Suppose I said that the absolute value of x was 8. Can you see that x would either have to be -8 or +8? In other words, this equation has 2 solutions. The absolute value of x equals 8. X has to either be -8 or +8. Any questions about that example? Okay. Let's say I want the absolute value of x equals 12. Well, can you see that if x was 12, this would be true because the absolute value of 12 is 12. Or x could be -12 because the absolute value of -12 is also 12. So for this equation, there are 2 solutions. X is what's outside or the opposite of what's outside, 12 or -12. Again, any questions there? All right. Let's say we've got the absolute value of 2x plus, or let's see, 2x plus 4 equals 16. So that means what's inside has to either equal 16 because the absolute value of 16 is 16, or what's inside has to equal the opposite of 16 or -16 because the absolute value of -16 is 16. So we get, again, these 2 equations, only now they aren't solved already like the previous ones were. So I need to go back here. And let's see here. And solve each separate equation. 2x plus 4 equals 16. Subtract 4 from both sides. 2x equals 12. Divide by 2, x equals 6. 2x plus 4, I can't talk today, it must be Monday, equals -16. I'll subtract 4. 2x equals -20. Divide by 2, x equals -10. Let's check our work, okay? Let's take x equals 6. If we put that up here, we get the absolute value of 2 times 6 plus 4 equals 16. Inside the absolute value bars, 2 times 6 is 12. 12 plus 4 is 16. The absolute value of 16 is 16, so it checks. Let's take x equals -10 and put that up here. The absolute value of 2 times -10 plus 4 equals 16. 2 times -10 is -20. -20 plus 4 is -16. The absolute value of -16 is 16, so it checks. Any questions?
What happens if one of the if either the negative or the positive version of the absolute value, if it doesn't solve correctly, what happens then?
Then it would not be included as a solution. You'd cross it out and you might just have one solution, let's say. It's possible. Go ahead, sorry.
No, that was it.
Okay. It's possible, and we're going to look at these. We're going to have some problems with one solution. This one had two solutions, and we're going to look at some with no solutions. Okay. All right. Now, let's take this for instance. The absolute value of, let's say, 3x plus 9 equals 0. All right. So that means what's inside has to equal 0, or what's inside equals the opposite of 0. But what is the opposite of 0?
There is none.
It's just 0.
Yeah.
So basically, these are the same equation. So in this case, you'd only get one solution. Okay, x is -3. Let's check that up here. Let's see. 3 times -3 plus 9. We get what? The absolute value of -9 plus 9, which is the absolute value of 0 equals 0, 0 equals 0. Okay, so here's a case where there's only one solution. Let's look at another situation. All right. The absolute value of 4x plus 12 equals -10. So 4x plus 12 equals -10, or 4x plus 12 equals the opposite of -10. If 4x plus 12 equals -10, we'll subtract 12 from both sides. 4x equals -22. Divide by 4x equals -11/2. Okay? Over here, 4x plus 12 equals the opposite of -10 would be +10. We'll subtract 12 from both sides. 4x equals -2. Divide by 4x equals -1/2. All right, so now I'm going to check both of those answers. Okay. Let's take the -11/2 and put that up here. So I get the absolute value of 4 times -11/2 plus 12, close it up, equals -10. 4 times -11/2, the 4 and the 2 would reduce down to 2/1. 2 times -11 is -22. -22 plus 12 is -10. So I get the absolute value of -10 equals -10. But what is the absolute value of -10? It's +10. Does 10 equal -10? No, it doesn't. So that solution is not correct. Let's go to the second solution. Let's check our work there. Let's see here. Absolute value of 4 times -1/2 plus 12 equals -10. 4 times -1/2 would be 2/1 times -1. So we get -2 plus 12, which is 10. The absolute value of 10 is 10. 10 equals -10. Nope. So this one has no solution. All right. Now, these solutions are called extraneous solutions, and they don't work. You could look at this problem at the very beginning and see that there's no solution because an absolute value can't be negative. However, what WebAssign has you do, rather than just write no solution, they will often ask you to find the possible solutions and then say whether they work or not, and it'll tell you in the directions about that. So this would be a case of where there are two solutions. They're called extraneous solutions. They don't work. Okay, so a case like this, there's no actual solution. A case like that, there's one solution. In a case like that, there could be, or there are, two solutions. Now, let's say we have this scenario. 2 times the quantity x plus 4 minus 6 equals 10. Okay. Before we split this up into the two equations that I've been doing, we need to isolate the part of the left side of this equation that is just the absolute value. So I need to get rid of the minus 6, and I need to get rid of that 2 multiplier out front first. So I'm going to add 6 to both sides. Divide both sides by 2. And then I'll split it up into what's inside equals what's outside, or what's inside equals the opposite of what's outside. But you've got to isolate that absolute value before you split them up. Otherwise, things don't work out so well. So now, solving those two, this one on the left will subtract 4, x equals 4. The one on the right will subtract 4, x equals negative 12. Let's take this and put it right there. Okay, so checking it, I'm going to go back to my original equation. So I've got 2 times the absolute value of 4 plus 4 minus 6 equals 10. Well, 4 plus 4 is 8, and the absolute value of 8 is 8. So I get that. 16 minus 6 equals 10. 10 equals 10. This one checks. Okay. Let's see if I can cram that second one in here. If x is negative 12, I get 2 times absolute value negative 12 plus 4, close it up, minus 6 equals 10. 2 times the absolute value of negative 8 minus 6 equals 10. 2 times, but the absolute value of negative 8 is 8, minus 6 equals 10. 16 minus 6, 10 equals 10. And they both work. But again, you've got to isolate this absolute value before you split it up into the two possible equations. Any questions there? All right. Let's say we have this situation. We have an absolute value equal to an absolute value. Okay. So there's nothing but 2 absolute value terms. All right. Well, looking at what we've done before, it seems like there would be 4 possibilities. You could take what's inside the first one equals what's inside the second one. You could take what's inside the first one equals the opposite of what's inside the second one. You could take the opposite of what's inside the first one equals what's inside the second one. And you could take the opposite of what's inside the first one equals the opposite of what's inside the second one. Okay. But if you start looking at it more closely, you see that closer, I don't know, anyway. These two are actually the same equation. If you take this top equation and multiply both sides by -1, you get the bottom equation. So we don't need that. It's redundant, so to speak. These two are also the same. If you take this top equation, multiply both sides by -1, you'd get this equation. So what do we end up having? We basically have what's inside the first one equals what's inside the second one. What's inside the first one equals the opposite of what's inside the second one. Those other two equations, we just get the same solution. All right. Let's see. Let's go back and let's solve those two. Give myself some room here. Okay. So let's take the 4x minus 7 equals 3x minus 21. I'm going to subtract 3x from both sides. X minus 7 equals -21. Add 7 to both sides. X is -14. The second equation, I'm going to distribute the negative and get negative 3x plus 21. I will add 3x to both sides. 7x minus 7 equals 21. Add 7 to both sides. 7x equals 28. Divide by 7, x equals 4. So I've got negative 14 and 4. Let's see if that works. I'm going to put negative 14 there and there. So I'm going to get the absolute value of 4 times negative 14 minus 7 equals the absolute value of 3 times negative 14 minus 21. Okay, this is where I wish I had or didn't write so big. 4 times negative 14 would be negative 56. Negative 56 minus 7 would be negative 63. Over here, 3 times negative 14 would be minus 42. Minus 42 minus 21 would be negative 63. Okay, well, I've run out of room, but what's the absolute value of negative 63? It's 63. What's the absolute value of negative 63? It's 63. The 63 equals 63, so it checks. Okay, now let's take this one and put it in here and here. Okay, let's see here. I'm going to put it up here so I have some room to write. If I put 4, I'm going to get this. 4 times 4 minus 7, 3 times 4 minus 21. 4 times 4, 16 minus 7, absolute value of 9. 12 minus 21, absolute value of negative 9. Absolute value of 9 is 9. Absolute value of negative 9 is 9. 9 equals 9, and it checks. Okay, so let's recap. If you've got, oops, let's see here. No, went too far up. Here. So if you got an absolute value already isolated equals a number, if that number is positive, you're going to have what's inside equals what's outside, or what's inside equals the opposite of what's outside. Solve both equations, check your work. If you have an absolute value equal to 0, you only get one unique equation because the opposite of 0 is still 0. So set it equal to 0, solve it, check your work. If you have an absolute value equal to a negative number, you're not going to get a correct solution, but go ahead and create both equations, get those solutions, check that they don't work, and then follow the directions in WebAssign. If you have an absolute value equation that doesn't have the absolute value isolated, do that first. Get rid of any extra stuff outside, and then what's inside equals what's outside. What's inside equals the opposite of what's outside. Solve the equations, check your work. And finally, if you have an absolute value equals an absolute value, take what's inside equals what's outside, or what's inside equals the opposite of what's outside, go through and solve them. It's possible to get 2 solutions, but only one of them works. So you always want to check your work. All righty. Any questions? I'm going to go ahead and